In this video, I would talk about creating distributions from data. I will demonstrate how to use Excel to create frequency distributions for categorical data and for quantitative data, as well as histograms. Let's get started. So when we are analyzing categorical data, we often use the frequency. So frequency distribution is basically a summary of data that shows the number of observations, that is the frequency, in each of the classes. And such classes are usually non-overlapping. So in order to do that, we need to define bins so that we can create a distribution, like count how many observations fall into each bin. And these bins should be the same size. So here we have an example of 50 soft drink purchases. Each purchase is for one of the 5 popular soft drinks, which defined the 5 bins, and they're categorical, meaning they're text-based, not numerical-based. So there are Coca-Cola, Diet Coke, Dr. Pepper, Pepsi, and Sprite. So the frequency distribution of soft drink purchases will show how many soft drinks are purchased in each category. So for example, we can see that there should be 5 purchases of Sprite and 19 purchases of Coca-Cola. So we know that Coca-Cola is the best selling and the Sprite is least selling soft drinks. Next, I'm going to demonstrate how to create a frequency distribution in Excel. So here we have the original data in Excel. So before we process, it's probably easier to put them into a single column because we're going to use a function called unique to find out the unique categories. So in the C column, we're gonna use unique. And then the unique function takes the range of the data. And so we have 5 categories: Coca-Cola, Diet Coke, Pepsi, Dr. Pepper, and Sprite. Now with the unique categories, I can use the COUNTIF function to find out the frequency count in each category. So COUNTIF, you need to specify a range and criteria. So for the range, we're going to specify all the values in a column. And for the criteria, if the value matches Coke, then we're gonna count it and put it under the frequency count for the Coke. And we do have 19 Cokes. Then let's copy this formula to the rest of them. And then we have a total, which is the sum up. And we should have total 50 soft drinks. So now we have the frequency count. This is the frequency count. We can calculate the frequency percentage or relative frequency. So the relative frequency is how many numbers of reservation in a certain category versus total number of reservations. So relative frequency is how many numbers of observations in a specific category versus the total number of observations. So here it equals to 19 divided by total, which is 50. And then let's copy the so it seems like copying the formula doesn't work. And let's find out why. It's because as we copy, the formula also changes. However, in this formula, we only want the first part to change, but not the second part. The second part we want to be consistently equal to this D7. So in order to do that, we need to use an absolute address of D7. So in order to change D7 to absolute address, you can highlight the number and use a function F4 and press enter and then copy. Or you can just manually enter $ in front of the column name and in front of the row number. Either way. So this way it doesn't change when you copy the formula. And then our total should be 100%. So the relative frequency will be 0.38, 0.16 for Diet Coke, 0.26 for Pepsi, and so on. And the frequency percentage would be just multiplied by 100 and adding a percent sign. Okay, so that is frequency count and frequency percent. So going back to our slide deck, we can see the same results and how to create it inside using Excel and the relative frequency distribution and in percentage. We can also use frequency distribution to analyze quantitative data. So there are 3 steps are needed. First, determine the number of non-overlapping bins. So you can choose the number of bins. Then you want to determine the width of each bin. So the width of each bin would be determined by largest data value in your data set minus the smallest data value and divided by the number of bins. So that's a formula for calculating the approximate bin width. If you have a decimal, then you probably want to either round it up or round it down. So you want to determine the bin limits first. So here we have a year-end audit times data set. It's measured in number of days. So we have 20 values and the number of data items is relatively small, only 20. So we choose to develop a frequency distribution with 5 bins. So the largest data value is 33 and the smallest data value is 12. So because we decided to summarize the data with 5 classes or 5 bins, so we use the approximate bin width equal to largest data value minus smallest data value divided by number of bins, which is equals to 33 minus 12 divided by 5, and that equals to 4.2. So we therefore decide to round up and use a bin width of 5 days in the frequency distribution. So we selected 10 days as the lowest bin limit and 14 days as the upper bin limit for the first class because we know that the smallest data value is 12. So we find 4 values fall in this range, and the smallest data 12 is included in the 10 to 14 bin. We could then select the 15 as the next lowest bin limit and the 19 days as the upper bin limit of the next class. We continue to define the lower and upper bin limits to obtain a total of 5 classes, 10 to 14, 15 to 19, 20 to 24, 25 to 29, 30 to 34. So the difference between upper bin limits and adjacent bin is the bin width. So using the first 2 upper bin limits of 14 and 19, we see that the bin width is 19 minus 14, which is 5. And with number of bin width and bin limits determined and a frequency distribution that can then obtain by counting the number of data values belong to each bin, and then we can use the frequency distribution to say that the most frequency occurred audit times are in the bins of 15 to 19 days because it has 8 data values in here out of the 20 total. So only 1 audit require 30 or more days. That shows it's the unusual case. So next I'm going to show you how to do this in Excel. So here we have the original data copied in here. Here we have total of 5 bins with their upper limit, and that should be sufficient for us to run the frequency function to find out how many items are in each bin. So in here, we enter the formula equal to frequency, and then we specify the data range, and then we specify the bin range, and then click enter. And we have 4 items in the 10 to 14 bin, and we have 1 in the 30 to 34, and we have 0 because this is greater than 34, and we don't have any data points that's greater than 34. However, if we change this largest 33 to 35, we can see this number change. Now we don't have anything in the 30-34 range, but we have 1 in the over 34 range. Okay, so I'm gonna undo this, and the sum should be the total data points, which is 20. So let's see, we sum it up, and that's 20 observations. So that's the frequency distribution for numeric values. Okay, these are numeric values. We can also similarly output the frequency percentage by dividing the frequency by the total. And remember, the total we need to do F4 to make it absolute address. And so then we can copy the formula, and we can see that the total should be 100%. So we can calculate the frequency percent this way. So here shows the here shows the Excel. You can do that, and here shows the frequency function in Excel. And we can also create distribution in a graphical format, which we call the histogram. So histogram is a common graphical presentation of quantitative data, and we can construct it by using the variable on the horizontal axis and frequency measure on the vertical axis. So each class is shown by drawing a rectangle that the base is the class limits of the horizontal axis, and the height is the number of the observation in that category, or the corresponding frequency measure. So in this figure, note that the class with the greatest frequency is shown by the rectangle appear above the class of 15 to 19 days. And the height of the rectangle shows the frequency of this class is 8. So histogram is basically a visual representation of frequency distribution. It should look something like this, right? So if you plot basically each being on the x-axis and the frequency of each being interval on the y-axis, you get a histogram. And then the histogram shows you the shape of your distribution. So you can see if you have more values in some of them and less value in some of them. If you skew to the right, like this graph, or skew to the left, it doesn't look symmetric. Usually you want to see your data set form a symmetric histogram. The symmetric is good. If your data is skewed and has a long tail on one side, that's usually a problem you have to fix. In many cases, in terms of diagnosis you want to do. And so it's always good to look at the histogram to see if you have a normal bell-shaped curve or not. In this case, it's slightly skewed to the right. So you can see a tail to the right, but overall it's not too bad. So next, I'm going to show how to do this in Excel. So we're going to create a histogram using the Excel function called data analysis. If you don't have this tool yet in your Excel, it should be coming with your Excel package regardless of the version. So in mine is the Mac version. I will find it under the tools, under the Excel add-in. It's both checked, meaning it's available. And if you haven't used it before, it may be unchecked. So go ahead and check it. If you don't see it over here, you can click the browse and point to the file that you can install it, and you'll probably be able to find the file from places like Microsoft Office website. So you want to click the data analysis and select histogram, and for the input range you want to select the data range, and for the bin range you want to select here the bin range, and we don't have any label, so leave it blank is okay. And for the output range, we want to choose it on the same page so we can see easily. And we want to make sure to check the cumulative percentage and chart output, so we can output a histogram as well as the cumulative percentage line. Then click OK, and you output nice little charts here. Let's make it larger to see. And then we can see that it outputs the frequency and the cumulative percentage as well. Basically, cumulative percentages keep adding up the frequency percentage, and towards the end is 100%. So we could also improve this chart by entering manually the range so that the bin range would show in this graph. So we have 10 to 14. We want to make sure it's a text field, so all this are text, and we want to say this is 15 to 19, and then 20 to 24, 25 to 29, 30 to 34, and it's greater than 34. Okay. So then we see that the bin range is being updated in the chart as well. We can also get rid of the gap between each rectangle in this chart. Basically, you want to select any of the bars or rectangle in the chart, right click and select Format Data Series. And then in the gap width, we want to make it 0%. So then they all kind of like connected together, look like more like a classic histogram. So histograms provide information about shape, form, or distribution. If you have skewness in a histogram, then it means a lack of symmetry. So it's an important characteristic of the shape of the distribution. You can have different shapes. So in here you see 4 different types. So in the top left, it shows moderately skewed to the left. So the tail extends further to the left than to the right. We say that skewed to the left. And examples like that could be exam scores with no scores about 100% and most of the scores above 70%, and only a few really low scores. So in the top right side, it shows the moderately skewed to the right. So the tail extends further to the right than to the left. And example can be housing prices. A few expensive houses create a skewness in the right tail. So in the bottom left, this one is symmetric. So the left tail mirrors the shape of the right tail. An example can be data for SAT scores, height and weight of people, and so on. It leads to histograms that are roughly symmetric. In the bottom right side, this shows a histogram that is highly skewed to the right. So example can be data on the housing prices, salaries, purchase amounts, and so on, often resulting in histograms skewed to the right in an extreme way. So you have very few cases, but they spread out in the range. So yeah, we also mentioned about the cumulative frequency distribution. Basically, it's a kind of distribution of frequency that provides a summary of quantitative data. And so basically, you just keep accumulating, whether it's the count of the frequency or the percentage of the frequency. So you count the total or like cumulative all the way to the 100%. So this is the creating distributions from data.